This video, we're going to kick off a discussion on logic. And in order to make that as easy as possible, we're going to use something that is called a decision tree. You may have seen something similar to this throughout your life. You may have seen it in school, or you may not have seen anything like this. But the concept is something we deal with in daily life, and that is decision making. Now, what a decision tree does for us is a decision tree allows us to graphically lay out the flow of the decisions that we need to make or are making when we need to analyze it or when we really need to thoroughly examine our decision-making process. So I've got a decision tree here, and it is a really simple decision tree, and we're going to run through it and we're going to see how Boolean logic, so that's how true or false, applies to a decision tree, or how we can apply it to a decision tree or a decision tree to Boolean logic. So to begin with, we usually start out with a question in our mind of, should I do this or should I do that, or something similar. And so in this case, I've got x in here, and x is going to be our variable, and it represents whatever it is we're trying to decide if we should do it. So in this case, maybe we'll use playing a video game. So a lot of times our students run into this conundrum, this decision that they have to make, whether or not they should play a video game or do their homework or clean their apartment or go grocery shopping, something like that. So it seems to be a fairly common decision that you'll all run into, or a lot of you will. And of course, you can replace x with whatever it is that you personally would need to decide upon. So here, should I play a game? Now, we're going to keep this really simple. When we ask that question, most of the time these questions are going to be true or false answers, or yes or no. Now, that is Boolean logic at its core. The questions have to equal either true or false, or yes or no, or 1 or 0. They all mean the same thing, all right? True, yes, and 1 all mean true in Boolean logic, and no, false, and 0 mean false in Boolean logic. So here, let's go through this really quick. We've got ourselves the initial question that we're asking ourselves, and then we've got two potential responses to that question. We've got a yes and a no. In this simple example, if we say yes, or if the answer to the question is yes without any deep thought, then we're just going to go ahead and we're going to do X. We're going to play a game. If the answer comes to no, in this decision tree, we see that it is followed by an additional question, which is, well, if we're not going to play a game, do we do something else? Is there something else that we want to do? And I went ahead and terminated this at, if the answer is no, really we have nothing else to do. So we're going to sit on the couch, stare at the wall, and do nothing. Pretty boring. So usually we're not going to pick no, but sometimes, man, we might be so dead from the day that staring at the wall might be fun. If the answer is yes, as a result of this question, then we go into a question, another question. What are my options? Like, what else is there for me to do in this day that I want to accomplish? Now, although this question right here does not necessarily end up in a yes or no response, as you can see, it actually comes out with a list of options. So this entire list is actually the answer to this question. The cool thing about Boolean logic and programming itself is that really it does turn out to be a true or false question in the end, because this right here, this list, we can actually turn into a list of yes or no questions once we convert it to code. And we call that a switch statement. So we'll see how that's done, or how we convert this list of many options to a single question into actual yes or no questions on each individual item in the list. And then by asking this question, we really end up asking yes or no on each of these individual questions. So we say, what are my options? I could take a nap. Do I want to take a nap? Yes or no. See how that turns into a yes or no? Same thing. What are my options? I can work on a hobby. Do I want to work on a hobby? Yes or no. And so that's how Boolean logic works in programming. Now, the nifty thing is that pretty much everything we do in programming boils down to a true or false statement. And based on that true or false statement, we then execute some kind of action. As we see right here, at the end of this yes on our right-hand side of the diagram, if we say, should I play a game? And the answer is yes, then it results in an action. We do X, so we go and we play a game. If it results in a no, like we got right here, well, it results in either another question or an action. So here it resulted in an action, here we're resulting in another question, and then as a result of the yes or no, we get an action. So we could think of this one right here as an actual action. So do absolutely nothing, right? So that is indeed an action. We're doing absolutely nothing. And then if it ends up being yes, then we come to another question, then we come to more questions, and then we could continue on with this diagram and talk about what happens or what steps do we take as a result of selecting one of these options. Now, the cool part is that once we get to something like that, we can actually just loop through our logic again. So here, as a result of our question that we asked, so what are my options? The cool thing is that once we decide which one of these through our yes or no's that we're asking on each of these items, we can then repeat our decision tree, which means we are simply going to take ourselves back to the beginning of our logic, and we're going to do the exact same thing again, just replacing play a game, which we stored in this variable x, with whatever it was that we chose out of these. Now that's simple Boolean logic. So really simple tree. The really interesting thing is that logic that goes through our minds, we do it really quick and it happens really fast in our brain most of the time. And we don't realize that the decision trees that we go through in our head super fast, almost lightning quick, are actually really quite complex trees of decisions that we have to make. So that's just a little bit too small, so let's go back to 100%. So here, we went through a little bit of our decision tree and we showed a repeat right there, or looping back for each of those options. But sometimes we will run into an action that results in a completely different decision tree. So right here, we have yes, I should game, we have no, I should do something else, but we actually did end up with something else that wasn't necessarily part of a true or false question. And this does happen as you are programming, and so you will have to handle separate cases other than just a true or a false. And so this is an example of diverting from a true or a false to, hey, maybe there's a third option that we need to think about. And then you can go back to a list type decision making situation. And so we could actually probably convert this into more of a switch statement rather than a true or false statement. But we'll leave that for another exercise. So if we go deeper into our thought tree, if we decide that, well, it's not really a yes or a no right now, in order to get me to a yes or a no, what I really need to do is I need to think about it. In other words, I need to go down a completely different set of decisions or true and false questions in order to really decide if I want to play a game. And that is where these more complex decision trees pop up in our everyday life. And these also pop back up inside of programming when we are trying to take real life, real world processes and procedures that happen within a business, and we are trying to apply them to computer logic in order to build a software system that can handle making these decisions or helping make these decisions in business every day at the speed of light, or at least help humans make those decisions with more information, better understanding as to why they're making the decision they are. Now, I went ahead and went further into this example. You can see that we kind of went past the yes or no on gaming, and now we're saying, well, why do I feel like doing it? So I'm thinking about it. I haven't made my yes or no decision yet. So I've gone into this whole nother tree of trying to figure out, why do I feel like doing it? Is it because I'm bored? Is it because I'm looking for a thrill? Is it because I'm stressed? Well, we have to ask ourselves questions about that, try to understand, in order to try to understand why or how we are going to make the decision of no or yes on whether we should do something. Now, this gets pretty complex. We'll go ahead and include this PDF with the video so that you can look through it and try to figure out where you would put in the decisions, where the logic goes, what you would identify as actions, what you would identify as questions, and see if you can't figure out how the logic works, and then go a little further. Figure out how you might change it based on the way you think. Not every single software system and not every single decision tree for each person is going to be the same, nor is it the same for every business process or procedure that happens out there in the world today. So understanding decision trees, understanding Boolean logic, and understanding how even lists of options can become Boolean decisions in a software system becomes extremely important in your daily life as a software engineer.